Already done, guys? If you want, you can take the screenshot of this. It'll have both the numericals, beta there. Taken the
Sir,
screenshot?
one question. Yeah.
Yeah.
So this in A question, this relationship between GMT and
So you tell now what all these things, how will they affect GM and K, beta? Answer based is the time taken by the vessel to complete one oscillation or one roll. One roll means what? She comes back to the same place after completing the full thing, and that is one oscillation. Okay, like you know what is one oscillation of a pendulum, likewise the oscillate one roll. If the ship starts from upright condition, then she goes to extreme on one side, then she goes to the other extremity, and she comes back to upright. And this is what completes one roll. Correct, guys? Yes or no?
Correct.
Yes, sir.
Or she goes from one extremity to the other, from port to starboard, and then starboard to port. That is also one roll. So basically, you know what one roll actually means. So either upright to extremity to upright, whichever way you want to take, it has to be one roll. Okay. What is natural period of roll, beta? Now, if a stable ship, which is floating in calm waters, is acted upon by an external upsetting moment, she would heal. And after she heals, you would withdraw the upsetting moment. And what will happen? The righting moment will bring her back. She'll gather momentum. She will not stop upright. She will go to the other side. Slowly, the amplitude of roll will dampen, and then she'll eventually settle in the upright condition. So what has happened is, you disturbed the ship with an upsetting moment. But after the upsetting moment was withdrawn, the vessel was rolling in calm seas at some period of roll that she was taking. And every time there was some amplitude of roll, which of course got gradually reduced and dampened. Now, whether this period of roll is less or more, going to be, if you have two sister ships, say floating at the same draft, they have different kgs. That means GM is different. If both are inclined by the same upsetting moment to 10 degrees to starboard and then withdrawn, both ships will roll. But both ships will not have the same period of roll, nor will the both ships have the same amplitude of roll. Why? Because they have different inherent properties of properties. Their kgs are different, leading to different GA. Okay, so therefore, different ships will have different period of rolls and different amplitude of roll. Rest everything remaining same. Okay. The upsetting moment is now withdrawn. The righting moment would tend to bring her back into the initial equilibrium condition. However, the angular momentum that the vessel gathers while returning would make the vessel roll a few times with reducing amplitude of roll before it settles to her initial condition of equilibrium. The amplitude of the roll dampens due to the resistance offered by water and air on the ship's hull. Such a roll, which is not influenced by external factors like wind and waves, but the vessel rolling in calm, still waters, where the rolling period and the amplitude is determined by the ship's own properties or stability parameters. If the ship is subject to roll based on its own inherent properties or stability criteria, not influenced by wind or wave, such rolling is called as the natural rolling, and the period of such roll is called as the natural period of roll. Is that clear, guys?
Clear, sir.
Clear, but okay. Now, this natural period of roll is the period of roll, whatever time the ship takes to complete one roll. We have just defined what one roll is. Now, in case of a pendulum, now like a pendulum, the ship's rolling is also simple natural rolling I'm talking about. The ship's natural rolling is also simple harmonic in nature. So they follow the principles of simple harmonic oscillations. And we know for pendulum in schools we have derived this formula, guys. Not to remember, but if you remember, this time period of oscillation for a simple pendulum was derived basis simple harmonic oscillation, where L was the length of the pendulum and G was acceleration due to gravity. Some of you may now be able to recall that there was something like this you did, right, beta? Correct? Exactly on the similar lines, following the principle of harmonic oscillations, the time period formula has been derived for a vessel, and the period of roll or time period of a roll for a ship in seconds is given by this formula. This is what you need to remember, beta. TR in seconds, time period of roll in seconds. This natural roll we are talking about is 2 pi k upon square root of GGM. Okay. Now, what is in this K? K is the radius of gyration about the axis of roll, whichever is the axis of roll about which the ship rolls. What do we mean by axis of roll? When the ship rolls, you see, if ship rolls to starboard, what happens? The deck part, upper part goes to starboard. The lower part goes to port. Okay. Now, if you see that as you are if you're on the mast, on top of a mast, when the ship rolls, you'll find that you've moved more distance for the same angle of roll. If you're on bridge compared to mast, you will move a smaller distance for the same angle of roll. You come down to your cabin, you will roll even less through the lesser distance. If you keep going like this, down, 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 somewhere there will be a point which will not move at all to starboard, nor would it move to port. So the point, so when you went to starboard, the person on the mast moved much more angular distance than along the arc. On the bridge, moved lesser, then lesser and lesser, and somewhere it will become zero. And below that point, below that particular point, other points would have moved to port, the opposite direction. This point which did not move is along our axis. That axis is called as axis of roll. It is like this, guys. If this is the ship, if this line represents the ship, and the ship rolls, let us say the ship rolls like this. This side has gone to starboard, lower side has gone to port. This point has not left that place. The line along this point is the axis of roll. So this radius of gyration is the radius of gyration about the axis of roll. G we know is acceleration due to gravity. GM we know is the metacentric height of the vessel. 2 pi k under root GGM. Okay. Now, how do we get the radius of gyration? Now, it's not, see, there are, in fact, it's very difficult to calculate the radius of gyration by taking the weights. In fact, we get the radius of gyration by using this formula measuring the time period. So for a normal ship-shaped vessel, this value of K can be roughly estimated. It's only a thumb rule, not binding. Is estimated to be about 0.35 times the molded breadth of the vessel. It's through experiments, you have found that this is more or less around this value. The derivation of this formula, which is 2 pi k under root GGM, is in any of the naval arc books, which you can refer to, but it's not required, so don't worry about it. Leave it. So please take down this formula. TR in seconds is equal to 2 pi k under root GGM, time period of natural roll of a vessel. Taken? Okay.
Yes, sir.
Ship's natural period of roll, if you see this timetable, this formula, timetable, if you see this formula, it is very evident. It's 2 pi k under root GGM. 2 pi k under root GGM. If you see this formula is not which is not influenced by the environment, It is only dependent on the ship's inherent properties. What are the inherent properties? One is the radius of gyration, which will depend upon the how the weights are distributed about the axis of roll, and it will depend on the GM. Which parameters does it depend upon? It depends on the metacentric height, and it depends on the radius of gyration about the axis of roll. What is TR? Now, if you see, TR is independent of the amplitude of the roll. When the ship is rolling, in the first roll, she may go to 7 degrees. In the second roll, she may go to 5 degrees. In the third roll, she may go to 4 degrees. Now, you see the amplitude is reducing. But with the reducing amplitude, the time period of roll does not change. So what is it saying? Time period of roll is independent of the amplitude of the roll. So when the ship goes to 30 degrees or 10 degrees, she will take the same period of roll. Now, how these factors which affect the period of roll, one is GM. How does the GM change? If you load weights, you discharge weights, or you shift weights, or you deal around with the free surface, then the GM would obviously change. How is K altered? K can be altered by loading, discharging, or shifting the weights on board with respect to axis of roll. And if you alter the K or the GM, obviously your period of roll will change. Now, the formula which 2 pi K under root G GM, where you see that once the weights on the ship are fixed, everything is done. If you see, the time period is inversely proportional to square root of metacentric height GM. So this relationship can be used to estimate the metacentric height of the vessel by measuring the period of roll. And this thing, the use of this property, that means using the time period of roll to estimate the ship's initial metacentric height, it can be done by through that process of what is called as a rolling period test. This rolling period test, guys, is also there in your cargo work. If you are yet to clear your cargo work in phase 1, then I'm sure you would have this in the cargo work as well. Okay, so this rolling period test is basically, you see, in the current code of intact stability, that is 2008 code of intact stability, there is no mention of it. But in the earlier code of intact stability, this guidance on rolling period test was captured as an annex to the code of intact stability. Okay, so it was there in the annex to the code of intact stability, the rolling period test. Whereas they had given the guidance on how to conduct the test and what all care to exercise. So there is a rolling period test which can be used to estimate the initial metacentric height of the vessel. However, the guidance of the IMO in that earlier code of intact stability was that they said don't use it for more than 70 meters in length. Of course, even less than 70 meters, there were some conditions. It's not that every vessel it fitted. But the whole reason was, what was the reason? That as the vessels become bigger and bigger, their keel becomes flatter and flatter and bigger. Secondly, the bigger ships have the bilge keels on the sides. Most of the merchant ships you would have seen in the dry dock, you have the bilge keel, right? The flat keel and the bilge keels, when the vessel rolls, they dampen the roll. They don't allow the vessel to roll freely. They try and force the rolling to dampen. And when there is a force which is acting, whether to roll or to oppose, then the rolling no more remains natural. And when it remains no more natural, then this formula for TR is equal to 2 pi K under root G GM will go for a toss. And therefore, in that earlier code of intact stability, where there was mention of this rolling period test, There it was said that it should be only used for small ships, and as a guidance they said up to 70 meters. Now let me just tell you, the questions have come in MD exams where they've given the length of the ship as 80 meters. Now if they've given you 80 meters and they want you to use this formula, please go ahead and use it here. What I'm telling you is what was the guidance in the Code of Index Stability preceding the 2008 version, right? So it was recommended for small ships, but if a 80-meter ship is rolling freely, then the test applies to 80-meter ship also. So there is no hard and fast rule like this, okay? It is something like this, beta. People say don't use the plain and parallel sailing formula should be used only up to 600 nautical miles. Okay, you set a limit. But if tomorrow, if I can use it for 590, I can also use it for 610. I don't think there will be much of error difference between 590 and 610. The error will be more or less similar. So, but somewhere, everywhere you have to put a limit. So the limit put like out here is 70 meters. What is the purpose? Is to recommend to the master of small ships. Why? Because of probably lack of competence to calculate. So if the masters don't or the skippers lack the competence to calculate, then such experiments can become easy way of for them to assess the stability of the ship. The test may be recommended as a useful means of approximately determining the initial stability of the small ships when, subject to, it is not practicable to give approved loading conditions or other stability information. So if somebody does not have the approved stability conditions or information, then yes, can the rolling test be used to assess the initial stability? Yes, provided the vessel is rolling naturally. As a supplement to such information, yes, it can be, you may have the loading manual and everything, the stability booklet, but this can be an additional thing for people to use as a supplementary check. What is the principle of this test? The initial metacentric height of a vessel is inversely proportional to the square root of to the time period of natural roll. Square root of GM is inversely proportional to the natural period of roll, and that gives a relationship between GM and period of roll. Okay, evaluation now. What has happened is because it is based on experiments, so a lot of inclining and rolling tests established. They further simplified this formula because we are recommending it to masters of small ships where competence could have been a challenge. So you can't be saying 2 pi k upon g into gm. Where is he going to get the k from? So for such use, this has been further simplified. Excuse me, simplified to what? Simplified to this. Okay. There is no derivation for this formula. Such formulae are called as empirical formulae, which have been arrived at through experiments, where it is basically based on the same formula, but further simplified for use on small ships or for a rapid use by the master. GM initial is equal to F into B upon TR whole square, where F is the rolling coefficient of the ship. Okay. B is the breadth, and GM you all know is the initial metacentric height, and TR is the period of roll. So this here already. So please take down this formula also. Questions come on this formula also. I'll show you the questions how they've come in MMD exam. So, but you need to remember this also. Okay.
So one small request, sir. One
Yeah.
small request.
Yeah.
So this notes, at least for this rolling, so can you please send, because I saw the Rohan D'Souza notes, sir. These notes are much better than what it is given into that note.
अरे
So it will
अरे
be of very.
अरे पहले पढ़ तो लेना मेरे भाई.
तो देखा
पढ़ने
सर.
के बीच में तुम्हारी चिंता नोट्स की ज्यादा हो जाती है, पढ़ाई की कम है. Okay. The factor F, which is very important in that formula, FB upon TR whole square, is obtained based on series of tests. So where is that going to come from for the ship? It will come from tests. F depends on type of ship. It depends on displacement and depends on distribution of the weights within the ship. So for the same ship, same displacement, with the change of distribution of weights, the F value will. In general, greater the distance of mass from rolling axis, obviously, the greater will be the coefficient. And because of that, the rolling coefficient of an unloaded ship. Why unloaded ship? Because unloaded ship will have the ballast in the tanks. It will have equipment on deck. The mass distribution is away from the rolling axis. For such ships, the coefficient will tend to be higher. Why? Because the radius of gyration will tend to be higher. On the other hand, a loaded ship, it will be loaded in the holds. The weight concentration will be more closer to the rolling axis. Therefore, the rolling coefficient will be relatively lesser. So the rolling coefficient of an unloaded ship will be higher than for a loaded ship. And the rolling coefficient of a ship carrying greater quantity of bunkers and ballast, why both of them are located in the DB away from the axis, will be higher than that of same ship having an empty DB tank. Some values of this factor F are basically typically arrived at, and those values are here. You don't have to remember these values, they are only for information. It's not that you have to mug up these values, no. You can see these are typical values of F. Empty or in ballast, it's higher, 0.88. Loaded, it's 0.78. So it's basically, you see the ballast condition value of F is higher than the. So these are the typical values of F, only for information. There's no point in mugging them up because they will be ship specific values, right? They cannot be generic for all the ships. Now, based on this, now I'll take you through the rolling period test later, but let's take some numericals. Explain how rolling period test is taken. What is the relationship between GMT and rolling period? Okay. What precautions must be observed when using this formula? August 2013 theory. Okay. Fine, but let's focus on the second part of the question. Find the still water period of roll of a ship when radius of gyration is 8 meters and metacentric height is 0.8. Which formula to use? 2 pi k beta? Yes or no? TR is equal to 2 pi k under root GGM, right? GM is given as 0.8. This you know is 9.81. Radius of gyration is given as 8 meters. Pi you know is 22 by 7. So this becomes the answer to this question. Very quickly you can get the answer and move on to some other question then. TR will come in seconds. Is that clear, beta? It's a MMD question, that's why it's being here, put here. Just to highlight the need of remembering the formula, correct, beta? The first part of this will be covered in the slides that follow, don't worry.
So 20 seconds are right, if anybody
Whatever it is coming, it's just simple calculation now.
Anybody did? Sir, just one doubt. Sir, this about rolling test. Sir, I think, I don't know if I'm not sure, I read in one of the codes, timber code. It's in one of the annex that
it was in the stability code itself, code of intact stability also. Earlier it was there, beta.
Yeah, so they said like you how to carry out, you have to make people run in unison. Then you have to
that was typically in the earlier code only. This is exactly what you're reading from there. Don't worry.
It's that only, no? You have to bend some mass or things like
they were talking about how these are the ways to induce rolling. They were saying how to induce rolling, right? How to make the vessel roll is what you're talking about, right?
Yeah.
Okay. Right, guys. Okay. Let's look at the other formula. Yeah, let's look at the other formula, guys. Now, this is what I was saying. Now, though the code was very clearly that it is recommended up to ships for 70 meters, but let's not fight over 70 and 80. If the question wants us to do it, let's do it, right? A coaster of length 80 meters, breadth 8 meters, has a rolling period of 10 seconds. If a rolling coefficient is 0.75, calculate her approximate. The word is approximate, guys. And we know GM is equal to F into B upon TR whole square. Correct, guys? Coefficient is 0.75, breadth is 8 meters, rolling period 10 seconds, whole square, get the GM. How much it comes to? So many meters.
0.36.
0.36. So again, as recent as November 2022. Again, taken up here to emphasize that the formula needs to be remembered. Formula needs to be remembered. Okay. See, you learn bilging, you learn moment of inertia, you learn everything. And then you have to leave a small question like this because we were not mentally prepared to take it up. Now, that is going to sometimes can make all the difference between passing and failing. And all your effort on topics like SFBM or bilging would go down the drain if it's not backed by these small topics if questions happen to figure from here, right, beta? So be careful about these small things. Otherwise, this is what he was trying to say a while back. Rhythmically lifting up and putting down of a weight as far off the midline as possible. Basically, you have to induce rolling. How you induce rolling, you are the best person on board. You can take a call on your ship how the rolling can be induced. Pulling on the mast with rope, that's what he was saying, running left and right and in unison. These were because you're talking of small ships. Small ship, when you're saying 80 meter, then this also can be used for a ship which is 40 meters, no? So small ships can be made to roll like this. Don't look at from the perspective of your 1 lakh tonner or 2 lakh tonner and say, how can the ship start rolling like this? So don't look from that angle. Look from a small ship perspective. In a live boat, if you have been in a live boat, when you move from one side to other, the list is developed, right, beta? So if a small ship, these activities are done, they can induce rolling. So don't be surprised. Any other means which you feel suitable for the rolling to be induced. The basic intention is to induce the rolling. As this forced rolling is commenced, because you are forcing the rolling to set in, then you stop any activity that you were carrying out to induce rolling and let everything settle down wherever it is and let the vessel settle into natural roll. Okay. Once the vessel settles into a natural roll, with the stopwatch, you can start counting. With a stopwatch, you can measure the period of roll. Do you measure one period of roll? No. Usually they say you should have 8 to 10 rolls in which you should measure the period for 8 to 10 rolls and then divide by that much to get the period of roll so that any error its effect is minimized when it is counted for a number of rolls that you may allow for. By means of stopwatch, time should be taken for not less than 5 of these complete oscillations. More the number of oscillations, better it is, depending on how much is the ship rolling. Allowing the roll to completely fade away and repeat the same operation at least twice more. From the observed time, obtain the time period. Whatever total time you get in one observation, divide by the number of rolls and you'll get the time period. And if you repeated this exercise 2-3 times, you can take the average of all and you can figure out what is the best time period that you can obtain. The period of natural roll thus obtained can be used to estimate the ship's initial metacentric height. The determination of the stability can be simplified. You see, even the master, somebody will say, sir, how will the master calculate this GM is equal to F into B upon TR whole square? If you're saying competence is a challenge. For that also, in the earlier code of intact stability, they had given a picture, a diagram in which through plotting, you could estimate the GM. And how did the diagram look like? The diagram looked like this, with this being the ratio line. This ratio line was ship specific, of course. This diagram was ship specific because if you shift this line to left or right, the values obtained would differ. So a diagram like this would be given to the master On the ship, this is ship specific. This ratio line will be ship specific, right? Where it is to be placed. Then you see on each y-axis, you have two scales. You have the rolling coefficient here, you have GM here. You have rolling period here, time, and you have the breadth here. So there are different scales on the axis. How this nomogram was to be used, I can take you through this example. For example, if you have to use this figure nomogram to obtain the GM, if F is 0.8, B is 9, TR is 12 seconds, how much is the GM? How this was used, let me just tell you. You see, first, what do we plot? We plot the F. Where is the F plotted? You can see the red one. Let me change to the laser so that I can show you use the laser. Here it's 0.8, right, beta? F, correct? Okay. And then on the other side, we mark the breadth of 9 meters. Where is 9 meters? It's somewhere here. The breadth scale 9 meter would be somewhere here. You can see it's come up now. Correct, beta? So what have we done? We mark the rolling coefficient F, we mark the breadth, and we join them with a straight line. Okay. Where does it cut the ratio line, the blue line? It cuts here, or the ratio line is cut here. Now, what is it that we have not used? We have not used the TR. Now, TR is here. This is the scale for TR. Mark 12 seconds of TR, the TR scale. It's 12 seconds here. Now, join this 12-second TR marking with M and allow it to be extended to meet this axis. Like this. And now on the GM scale, you can read from here the GM of the vessel 0.36. So through this diagram, such nomogram, which is ship specific, of course, it cannot be for every ship the same thing. The need to calculate was also done away with, and the GM could be estimated using this nomogram. Is that clear, beta? Clear? Limitations, I think they are straight and simple. We already know them. Test is recommended for only small ships up to 70 meters. Ship should be a normal ship-shaped vessel without bilge keel or any such form that dampens the roll. Test should be conducted with ship in harbor or in smooth water with minimum interference from wind and tide. Time should be observed for not less than 5 oscillations. If possible, when repeating the observation of time, in every case, same number of complete oscillations should be timed to establish that the readings are consistent, that is, repeating themselves within reasonable limits. The timing and counting of the oscillation should only begin when it is just that the ship is rolling freely and naturally, and only as much as necessary to accurately count these oscillations. The mooring should be slack and ship breasted off to avoid making any contact in the rolling, because any contact will dampen the roll. Care should be taken to ensure that there is reasonable clearance of water under the keel on both sides of the vessel. Weights of reasonable size which are liable to swing, example live boat, or liable to move, example drums, etc., should be secured so that they don't move when the vessel rolls from one side to another. The free surface in the tanks should be kept to as small as practicable during the test. These are the precautions for the rolling period test. Experiments have shown that results of the rolling period method get increasingly less reliable as the GM values approach low. They tend to be low. That means if they get to 0.2 and below, the results of the rolling period test become more and more unreliable. It is not generally recommended that results be obtained from rolling oscillations taken in the seaway. Why? Because in the seaway, she will be under the influence of waves, her own propulsion effect, and all those things will be there. Exact coefficients for test in open waters are not available. Rolling period observed may not be free oscillations but forced oscillations due to seaway. Frequently, oscillations are either irregular or only regular for too short an interval for time to allow accurate measurement to be observed. Specialized recording equipment is necessary. However, sometimes it may be desirable to use the ship's period of roll as a means of approximately judging the stability at sea. If so, it needs to recognize that the determination of stability by means of rolling period test in disturbed water should only be regarded as a very approximate approximation, and over reliance on such observations should be done with, or there should not be over reliance on such results.